Okay, my name's Professor Paul Dunn, and I'm responsible for delivering the module Comp 116, which has the title Analytic Techniques for Computer Science. And as you will see, and as many generations of students before you have seen, I have this rather irritating habit of prefacing my lectures with some pretentious literary quote. And so for the introduction, toute chose sont dites déjà, mais comme personne n'écoute, il faut toujours recommencer. I'm aware that translation is unnecessary. This was said by a famous French Nobel Prize laureate, the writer André Gide, and because no translation is needed, I'll give one. Everything has already been said, but since no one was listening, it must always be said again. So, what's this module about? Why are we looking at the topics in it? Where are we going to be studying these methods later on in computer science? And how exactly are we going to be proceeding with things? So, what are we doing here? What I'm doing is giving an overview of important methods and techniques which are used in modern computer science. Why are we looking at these? Well, the main reason is that many of the methods we'll be looking at, you're going to need, you're going to meet much, well, not much later on in the program of study. So this will be in subjects such as machine learning, data science, algorithm analysis, an idea called experimental computing, and in optimization. We're going to look at the main ideas over six main areas, six main topics. And how? Well, it's going to be a mixture of lectures, tutorials, assessed online tests. So, what are the topics we're going to be examining over the next 10 weeks or so? We're going to look at a notion which undoubtedly you consider yourselves already to be very familiar with. The notion of number, types of number, the concept of what I'll be referring to as a polynomial. We're going to do some quite basic in the first part, what is referred to as linear algebra. So this is vector manipulation, matrix methods. We're going to be looking at that topic particularly with respect to how these are used. And one of the most important applications is in the context of two-dimensional graphical effects. I'm then going to move on to something which is perhaps rather more challenging. The idea of calculus. I will say a bit about the background, how calculus originated as a discipline. I'll mainly be focusing on differential calculus, and we'll look at how calculus is used as an important tool in what are called optimization problems. I'll then go on to something which which may seem a little bit odd to have no connection with computer science whatsoever. And that's the idea of complex numbers, complex number analysis. Again, I'll talk a bit about the background to the idea of complex number theory. I'll say something about the different forms of complex numbers. Most importantly, I will focus on how these have fed into and inspired various ideas in computer science. I'll take a brief look at the idea of computer science as an experimental science, and we'll look at techniques which are important in experimental analysis, namely the topics of data fitting and what is referred to as regression. I'll then move on to a quite recent development, the use of advanced linear algebra, in particular spectral methods in computer science. And to finish off, I'm going to deal with a subject that was introduced in the module last year, although it has been part of the syllabus. I'll talk about a very important discipline, which is called information theory. How are we going to be doing this? Well, lecture resources. I have, following on from the having to deliver the module offline 3 years ago, a dedicated YouTube channel set up. This contains pre-recorded versions of every single lecture except this one, which will be added as soon as I finished recording it. There is a playlist specific to the delivery of this module in 2025, and that is at that location. Most of the pre-recorded videos are between 11 and 25 minutes in running time. PDF version of all of the lecture slides used is also given on Canvas. One of the advantages of YouTube arrangements, certainly in comparison with what the shambles that Panopto makes of them, is that all of these have corrected closed captions. What about assessment? There are going to be 3 class tests. These will be hosted as Canvas quizzes. They contribute, the first one 10% and the final 2 15% each of the final mark. The final exam itself, 10 plus 15 plus 15 is 40. That leaves 60% of the final mark being contributed by the exam. First class test will take place 20th of February at 3 o'clock. That will look at topics in the first parts of the module, namely numbers, polynomials, and vectors. The second class test will take place about roughly a month later, 20th of March, again at 3 o'clock. That will look at calculus and complex numbers. The final class test, that will be on the 8th of May at 3 o'clock. I'm unable to use, that should be Thursday the 8th of May at 3 o'clock. That will be looking at spectral methods, information theory, and language modeling. These will be taking place instead of the lecture scheduled at that time. So, probably you're looking at the sorts of things I've been saying will be covered in the course: calculus, complex numbers, linear algebra, and you may be thinking, so this is a maths course. No, it is not. It may look like a maths course, but this is a very famous painting by the Belgian surrealist René Magritte. Magritte's painting is an example of do not judge things by appearances. The French means ceci n'est pas une pipe. This is not a pipe. It isn't a pipe. It's a painting of one. So you are going to see a lot of strange symbols: upside down A's, backwards E's, V's, carets, arrow notations. Doesn't make it a maths course. You're going to see strange expressions such as the integral of x dx is the same as, whatever that means, d by dx x cubed divided by 6. Doesn't make this a maths course. You're going to see odd 2 by 2 matrix multiplications, odd bracket expressions. This is not a maths course. So, there is a course textbook which was published in 2019. It's published by a company, a firm called College Publications. The title of the book is Computation Counts. It's available from Amazon, and I do not receive a penny in royalties from it because I have asked that all royalties be donated to the Walton Center Neuroscience Fund. Word of warning: Amazon have, for reasons that I do not understand, occasionally hiked the price to £26 or more. I don't see any justification for this. I have complained to the publisher. It's a 5-year-old textbook and material has been added to the module which is not covered in the book. Amazon sometimes reduce the price back down to what it used to be. One thing I will say is please do not, there are so-called used copies retailing at ridiculous prices of close to £60. It is not worth paying that sort of money for a used copy. There is no justification for it. So, let's look at some more details. So, I mentioned numbers and polynomials. We're going to look at that section at the different types of number and how they arise in practical applications. We're going to look at the idea of what's called a polynomial function or a polynomial expression. We're going to look at the concept of what are called the roots of a polynomial. Then going to move on to basic vector and matrix ideas, particular operations on vectors, the idea of a vector space, and the notion of matrices, and this idea of what's called a linear transformation and the role it plays in computer graphics. I'll be then moving on to look at calculus. Calculus is ultimately based on a way of studying what are called functions. Particular important idea that is introduced in calculus is this notion of a first derivative. First derivative is important in analyzing what are called the critical points of a function, and the critical points of a function have a very important part in the study of optimization. Most of that initial work will be looking at functions which only depend on one argument. I'll then move on and say how we can try and use similar ideas to look at functions which depend on several variables. I may give a very brief overview of integral calculus. Equally, that may be omitted. So, we're then going to look at this strange idea of complex numbers. I'll say a little bit about the historical background leading to the origins of complex numbers as a object to study. I'll talk about the different ways of representing complex numbers and the equivalent ways of representing and operating on them. Something that was added a couple of years ago is the changes that have to be made to classical calculus in order for it to be applied to functions involving complex values. The important part is how have these helped in computer science? There are three principal areas, I would say, in the realization of effective three-dimensional graphics operations through a device called quaternions, in algorithm analysis and in efficient algorithms, and in one area of artificial intelligence which you may not meet later on in the program, but it is quite an important application of the use of complex numbers, and that's a field called computational creativity. What are we going to do next? We're going to look at some experimental aspects of computer science, in particular techniques for analyzing and presenting experimental results. I'll then go on to talk about spectral methods. As I said, this is a comparatively recent idea. It's a much more in-depth, sophisticated study of matrix properties. Particularly, it centers around something called the eigenvalue problem. So I'll give a definition of that. I'll talk about properties of eigenvalues and eigenvectors. And then, as I've focused in previous areas, we'll look at the applications in computer science. So those come from graph algorithms, from web searching, from image analysis. And finally, again, it's another topic that was covered in depth last year. It is not discussed in the textbook, and this is a very old discipline in computer science called information theory, and its application to what are called models of natural language models. So, I will start off by introducing what is called the Shannon model of communication after the great American computer scientist Claude Shannon, who was active in the late 1940s, early 1950s. We'll introduce the notion of what is called information entropy and a very important result called the source coding theorem. I'll briefly discuss methods for dealing with interference, dealing with noise, and I'll finish off by looking at how all of this feeds in to the notion of language models, in particular predicted text, as you may have seen used in editors such as Word. How does an editor, as maybe set up, predict the next word that you want to type? I'll talk about this model of n-grams and the uses of n-grams. If you want to get in touch with me, you can email me at that or that, or one which is an indicator of how long I have been around, this email address. Any one of those three will work. Uh, the web page for the module, that's the address there. And the Canvas details, those are the Canvas course is provided at that link there. My office, room 204 in the Ashton building. So, thank you for your time. I look forward to seeing you and working with you over the next 10 weeks.